Hello everyone. In this video, I'll be explaining how to graph a logarithmic function. So plot this function. Function of x is equal to 5 log base 2 of 2x minus 4 minus 10. So there's a few things to recall. First, logarithmic functions is an inverse of the exponential function. Also, they have the similar shape of square root functions at first glance. A few approaches might be to find the domain, range, transformations, asymptote, and some key points of the function. Now step 1. Determine the domain and range. Given a log function of x equal to log base b of x, the domain is x is bigger than 0 or 0 to positive infinite, as b to the power of anything is still positive. Now the range here is a set of all real numbers because b could be to the power of anything. So step 2 is going to be identifying the base. So given this function, b is going to be the base. B has to be bigger than 0 and not equal to 1. If b is bigger than 1, the curve is increasing from left to right. If b is in between 0 and 1, then the curve is decreasing from left to right. B can't be equal to 1 because then the exponent has to be equal to 0. Now step 3 is to determine the transformations. Here, h means the horizontal shift, so from left to right, as it's directly connected to the x value. K means the vertical shift, as it doesn't change the shape of the function, but it changes the vertical value. Now the vertical stretch and compression is changed by A. So A can change if the graph looks stretched or compressed. Now the reflections are caused by A and by if x is negative, then x. When A is negative, then there's a reflection over the x-axis, and when x is negative, there's a reflection over the y-axis. So step 4 here is going to be to find the asymptote. So given this function, we can find the vertical asymptote by setting the argument to 0. So when this is equal to 0, that means when x is equal to h, there is an asymptote because this is the result of b to the power of something, and b to the power of something can never be equal to 0. So now we have an asymptote. But there is no horizontal asymptote because y, or the exponent, could be equal to anything. So step 5 is going to be to calculate the key point, or the interception, with the x-axis. So given a log function this, all functions have an x-intercept of 1, 0, because when x is 1, you know the y, or the exponent, was 0. There is no y-intercept in this basic log function, as log b of 0 is not defined. So no number to the power of anything can be equal to 0. Now step 6 is going to be to calculate other key points. So we could select x values that are power of the base. For example, x is equal to base to the power of 1, base to the power of 2, base to the power of 1/2, and list the x values with the corresponding y values to find a few coordinates of the function. So now here, when x is equal to b, y is equal to 1. When x is equal to b squared, y is equal to 2. When x is equal to, and so on. Now step 7 is going to be to find the reflections of the exponential function. It's useful to know the graph of a logarithmic function because it's the flip of its corresponding exponential function across the line y is equal to x. This feature allows you to think the line trend. So step 8 is going to be a summary of the key features for this function. The domain first is going to be all the possible values for x. So now x is bigger than 2 because this has to be bigger than 0. And if you calculate it, then x has to be bigger than 2. Range is going to be all the possible values for y. And here, y is element of negative infinite to infinite because the exponent could be anything. Now the base here is going to be 2, And because it's bigger than 1, the curve is increasing from left to right. The shifts are going to be 2 to units to right, because this can also be written as 2 times x minus 2. So yeah, it explains this. And because it's minus 10, it's 10 units downwards. The asymptote is going to be x is equal to 2, because when x is equal to 2, the result of the base over to the power of the exponent is going to be 0, and that should never happen. So this is a line that the graph is never going to reach. The intercept here, the x-intercept, is going to be when x is equal to 4, y is equal to 0, because when x is equal to 4, then 2 times x is equal to 8 minus 4, which is 4. Log base 4 of 4, log base 2 of 4 is 2, times 5 is 10 minus 10 is 0. So when x is 4, y is 0. And the key points are going to be, you're going to find a lot, but a few could be, so when 2x minus 4 is equal to 2, then x is equal to 3 and y is equal to minus 5, so we have this coordinate. And when 2x minus 4 is equal to 2 to the power of 6, then x is equal to 34, y is equal to 20, so we have another coordinate. So now by replacing a few values, we can really get a precise drawing of the graph. So for example, when x is equal to 2.7, y is equal to minus 7.5. When x is equal to 3, y is equal to minus 5. And here we have a graph for all the x values and all the y values. And here is a drawing of the graph itself. Now plot the following logarithmic function. This. So it's similar to the previous one, but there's a small difference. So a hint here might be to use the reciprocal rule, which states that the log of base 1 over b of x is equal to minus log base b of x. So it's basically just going to be a reflection over the x-axis, because when you have a minus in front of the function, it reflects over the x-axis. Now try this question. There's still a slight difference, and it's related to reflections. A small hint here is to understand that the log base b of minus x and the log base b of x reflect over the y-axis. So because we have a negative in front of the x, the function has been reflected over the y-axis. Thank you very much for watching. I hope the video was clear enough, and see you next time.